So welcome. This is a colloquium and discussion on the science of sustainability. So it's half day. It has two sponsoring organizations, the UM branch of the Institute for Complex Adaptive Matter and the UM Energy Institute. Mark Barteau of the Energy Institute will say a couple of words in a moment. I'm Jim Allen, and I'm sort of the Icam representative here, and I thought I might say just a little bit about Icam. Institute for Complex Adaptive Matter, this is the website, and I put that up there. I'll show it again with malice aforethought. It's an international and national institute. There are more than 50 branches worldwide, so this gives you some idea of the distribution of branches. This is probably already a little out of date. There are probably ones here and a few more there and a few more here. So it really is international in character. And it's devoted to fostering research and public outreach on the topic of emergence. So I wanted to just say very quickly this idea of emergence. I mean, it is basically the idea that you have a collection of many similar objects, and they even can be quite dissimilar, that mutually interact, that you get new properties that are characteristic of the collection and not of the individual members. And just as a couple of quickie examples, if you have one or a few H2O molecules, you would not say that's wet. But if you have lots of them, then they acquire that property that we would call wetness. And on a grander scale, we might say, how can a collection of molecules, that's us, think about what molecules are? So this is a little bit of an idea of what this concept of emergence is. So sustainability, which is the topic that we have today, is clearly an emergent concept that flows out of physical science, technology, social ecological systems. So it is a very complicated topic that I think you'll catch some sense of that. I don't know whether any of the speakers will use the word emergent. We didn't ask them to, but I think you'll see as we go along that this concept is somehow very much connected with sustainability. So the last topic that I wanted to mention it's just that there are some opportunities for Icam funding for UM faculty and students. And I'll just mention these quickly, so I'm advertising now a little bit that as a result of UM being a branched institute, there are the possibilities of some resources to flow. It's possible to get up to $25,000 of support for exploratory research, exploratory workshops that you would propose to the Icam board. This isn't typically enough to support a whole workshop, but it goes a long way when you go to talk to a dean to say, I already got $25K in my pocket, how would you like to help me out? So this could be pretty nice, and we have actually had 3 or 4 of them here at Michigan. We've been quite successful in competing for the funds, and I would like to see that happen more. There are travel awards for junior scientists, so graduate students or postdocs or people even a little more senior to go to either Icam or other meetings or to make short research trips. So these can be used to augment existing grants. There are exchange awards for junior scientists to carry out long periods of research at other Icam branches, and also a few exchange awards for senior scientists. The details and the specifications and info are all at the Icam website. So it's icam-i2cam.org. The I2CAM stands for International Institute. So that's really all that I wanted to say about as an introduction to Icam. I will just mention that we have one upcoming activity on April 5th that might or might not be interesting to some of you. I put a couple of these brochures in the back. This will be a day-long symposium on the origin of life. So we have 5 rather prominent speakers coming to discuss this rather interesting topic, and that again is clearly an emergent kind of a phenomenon. Okay, so then I wanted to just give Mark Barteau a few minutes to say something about our session today, and then we'll move on to our first speaker.
Great, thanks, Jim. I don't think I need the microphone either. I will say Jim and I actually met for the first time today. So our entire collaboration on this activity was done electronically over the past several months. I suspect that many of you in this room, as I have described energy and the environmental consequences of its generation and use as the grand challenge of our time. I certainly believe that, and I'm sure others do as well. And I think many of us have been engaged, continue to be engaged in trying to communicate that and possible paths forward to many groups, students, community organizations, colleagues, members of Congress, whoever. And when I usually start by trying to get across the enormity of scale of our energy and sustainability challenges. And for those who aren't always mathematically inclined, even that can be a difficult concept. Once you get past that, then some folks tend to see the world in rather binary terms. Green, sustainable, renewable, organic, natural, that's good. Fossil and other things are bad. And of course the world is more nuanced than that. And then if you're lucky, maybe your audience is at least capable of thinking of things in linear fashion. But that means they may extrapolate from their experiences in some rather unfortunate ways. So, I think what we realize is that the world isn't a linear place, that many of the kinds of things that we're going to be talking about today involve coupled systems. They involve feedback loops that we may not fully understand or be able to describe. And of course, all of this involves human beings. So much for actually being able to predict behavior. So I think that's part of the challenging background behind what our speakers will talk about today. I really hope to get a couple of things out of this myself. One is a deeper understanding of these kinds of issues. But I'm particularly interested in learning from our distinguished speakers today how they communicate some of these ideas to different audiences that may have different levels of sophistication to absorb them. Because I think we all love to take good ideas and apply them in our own teaching and communication. And I'm hoping to come out of this with a few of those. So Jim, I'm going to turn the floor back over to you to introduce the first speaker, but I'm delighted that you're all here and looking forward to a great afternoon.
So maybe before I do this first introduction, I will just comment that Mark Barteau has been absolutely magnificent collaborator. I have to say that he had a zillion good ideas. There was never an unanswered email and no loose ends left hanging ever. And that's about as good as you can do. So I'm very grateful for this interaction. So our first speaker today is Peter Littlewood. Peter has a PhD in physics from the University of Cambridge. He spent a fair period of time, 17 years at Bell Labs, in the days when Bell still probably had its character that it had traditionally many years in the past. He was eventually head of the theoretical physics department there. He then went back to the University of Cambridge, and he served as the head of the Cavendish Laboratory and the Department of Physics. Recently, he has come back to the United States, and he is now at Argonne National Lab. He's the Associate Lab Director for Physical Science and Engineering, and he is also Professor of Physics at the University of Chicago. He is a Fellow of the Royal Society, and his research area, I would say in general, is theoretical condensed matter physics. At Argonne, he does that, but also has a focus on materials that are useful for energy. So today he will talk to us about the physics of sustainability.